We have Mr. Rahul Bedi. He's the Senior Director of the IoT Group at Intel. Rahul is currently the Senior Director of the IoT Engineering Group at Intel India and leads a team responsible for the development of various IoT products. Earlier, he managed the mobile software engineering team and led the development of Cherry Trail-based Windows tablet. Prior to this, Rahul was the Director of Software Strategic Planning at Intel in the US and drove the software aspects of Intel SoC long-term product roadmap. Earlier, he played different roles, including Director of Corporate Affairs at Intel Southeast Asia and India, and India Business Operations Manager. So Rahul's talk today is going to be centered around opportunities for design solutions in IoT. He's going to be talking about the evolution of IoT, how it went from a disconnected to a connected to kind of autonomous devices, and what are the design solutions required as we go from pilots to scale. So welcome, Rahul.
Thanks for having me here. Can you guys hear me okay? I can't figure out. All right, great. So that was just a quick intro in terms of what Intel does. You would have heard of Intel as a company that does the stuff that goes in the PCs and many other things. But IoT is a big growth segment for the company, and we've been in this space for a very long time before it was called IoT. Right? I mean, IoT has been around for a long time with different names, embedded, call it different things, and it continues to evolve. So, so what I'm going to do is basically the talk is in two segments. I'll cover about kind of broadly the IoT evolution in terms of how things have been evolving. And then we'll talk about how to make things less harder, right? We've talked about how hard it is. Martin talked about some interesting aspects on security. We'll talk about some of those too. And then talk about some of our experiences and what we're bringing to the market in terms of allowing people like yourself and other practitioners to make it less harder and more scalable to actually make money with this damn thing, right? So that's what we're going to talk about. Go to the next poll, please. No. So IoT, the way I look at it, IoT is different than regular adoption of technology, right? Because of the fact that it's a thing, we have so many things all around us, and things make life different from us. Things make life easier for us if we do it well. Things make it life very difficult for us if not done well. So IoT as a concept is unique that it touches pretty much everything that we do, everything we experience every day in our life, right? You see some of these examples, right? There's agriculture in terms of how do you make sure that you've got yields go up. How do you make sure that this a remote farmer somewhere across the country is able to kind of grow the right things into the right things to get the right yield as we go along. Or you're looking at security, right? We talked about security, but you're looking at digital surveillance. You're looking at what's going on in the world around us. How do you make it a safer place? IoT plays a very important role in that area. You're looking at things around optimizing efficiency, right? We're talking about creating industries that are able to make more money by doing less. That's a little bit of a dichotomy, but how do you actually get more efficiency? How do you get more productivity from what you're trying to do in industrial environment? So those are some of the things that IoT touches, and because of the fact that it's basically a device or something that was previously not connected, now it's getting connected, there are a lot more things we can do, and that's what we're going to talk about. So let's talk about how IoT has been evolving over the last, I don't know, decade plus, if you may, right? So look at it read it from the left to the right. So the first and foremost thing really has been you've got a thing, the thing's got to be connected, right? It's Internet of Things. And so the first and foremost challenge that we've been facing in the industry is how do you get things that are disconnected to actually start connecting with each other, right? So that's been the first phase of IoT. The second phase is now you got them connected, they're talking and doing something, God knows what they're doing, but doing something. How do you actually make them smart? How do you actually have them understand what's kind of going on? How do you kind of have analytics coming in? How do you make things that will basically have something useful done because you got data flowing back into the cloud or elsewhere? So that's the second phase. And the third phase, where we all are aspiring to go to, we are not really fully there yet, we're slowly getting there, is autonomous. Now you've got connected things which are sending in data, and now you've got something which is allowing them to make decisions by themselves, right? Which are autonomous. So these are the different phases of IoT. Now, I wish I could say that the entire industry is, I don't know, somewhere in the middle, right? I can't. Because the reality is that different industries have different levels of evolution. There are certain industries that are actually not even on the page right now. They're on the left somewhere. They're still figuring out how to actually get the thing to connect. They're there. They're true. They're very profitable industries, but they are there in that stage today. There's some industries that are kind of becoming more towards autonomous, right? Self-driving cars, you're getting there, right? So you have a big spectrum of how industry is, and that's the interesting part of where IoT is. Now let's look at it from a different perspective. You've connected things, and when you connect things, you generate data. And the data, if you look at the graph, which you unfortunately can't read, but what you'll see is the dark blue is real-time data, and it's talking about as you go till next about 5 or 6 years, you see the exponential rise in real-time data that IoT machines and things are generating. You're talking about the darker or a little less dark blue, which is IoT data, right? And you're talking about the lighter blue, which is other data coming out. Look at some metrics here, right? Average internet user 1.5 gig of data a day. Somehow at my home, we hover around 10 gig a day. I don't know, something's wrong with us, but that's typically what happens in what we do. You look at a kind of a smart factory, 1 petabyte of data a day. Huge, right? This data is something that's kind of becoming unmanageable to an extent, right? So the other aspect that we found is that 50% of IoT rollouts that will start happening starting next year are going to be significantly network constrained. Big challenge, right? When you're connecting all these things and you can't get the data to where you want to go, how do you deal with that stuff? That's a big problem the industry has. So what's happening is, and in the evolution, you'll find that we've talked about things, we've talked about cloud, we've talked about networks. What's also being talked about a lot is about how do you bring more computing and how do you bring more intelligence to the edge, right? Because you have to process the real-time traffic. You're driving in a car or a self-driving car outside, I don't know when, maybe some point in time we will. You have a cow coming in front of the car. What do? You go back to the cloud and wait for the spinning wheel to say, well, that's a cow, stop, or do you have to take real-time action? You have to be real-time, so you have to process the data close to the edge, and that's where the industry is going. We have talked about the cloud, we've talked about the absolute things, we're also talking about how do you make more and more compute happen at the edge. So that's something I'll talk about in the next couple of hours as well. So this is just a glimpse, and I realize that you can't really see it very well from the back, but effectively what it's talking about is few key domains and key challenges that some of these segments have. For example, if you're looking at video analytics, you've got to make sure you got connected, and you've got to make sure you're analyzing things real time on the device itself. You've got a camera looking at something wrong happening. It's got to be able to understand that without having to wait for poor connectivity to send it back up to the cloud and bring something back again. So that's the stuff. So you have things evolving and happening at the edge, and you also have this concept of fog computing, right, which is effectively creating more and more capabilities on the edge rather than relying everything to happen in the cloud. You do need the cloud, but you also need something at the edge, which is what fog computing is all about. So let me kind of move forward and more in the context. With that context, let me talk about more in terms of deployment challenges, right? I mean, very interesting you see beyond the high pilots to scale. It's a pretty interesting theme for the event because the reality is we have a lot of challenges. We heard it's hard, we heard about security, and here are a few more. In our experience of how we're building some of these devices and solutions is what we've seen is broadly 6 categories of challenges that the industry faces today. The first one, which is security, that we've heard Dr. Martin talk about in immense detail, so I will not go into that much detail, but it's interesting as he was talking about the stuff, I was saying, gosh, did we steal our foils, right? The reality is, the industry, we all are facing similar challenges, right? So here's some of the things. So if you look at it, I mean, it starts right at the bottom. It starts fundamentally from how do you design the security at the foundational level. Security is not an afterthought. It's not something you can build a product and say, oh, security tool, let me build it. It's too late. It starts from ground up. That's what it needs to happen. I'll give you an example. Security is hard, right? If you look at things like APIs or how do you actually program something to be secure, you know, you don't have to be a PhD in security to be able to do that stuff. You got to be a simple guy off the street or a simple programmer to actually use that stuff. And so what we've been trying to do is simplifying some of these things. It's really important to have a simple API. It's really important to have a standardized API. You build it once and you can trust that the foundation is there, it'll work, right? That's important because someone will break it, someone will hack it, that's the way it is, right? The second part really is in terms of you build a chip, you've built a kind of an ingredient that's secure, but the problem is when you tie 6 things together on a platform, they all have to work securely together. You have one weak link and that's it. That's where it breaks, right? So you got to make sure you got to have a platform which is secure, and aspects of that really come in terms of how are you creating solutions that are ready for security, which is the second part of the tiering game. And the last one really is how do you ensure that you've got kind of the whole life cycle, right? So I'll give an example let me move forward here real quick, right? So you're looking at an IoT enabled bulb, right? Simple bulb, smart light. The cities are going to have hundreds of thousands of those, right? How do you bring that on board? Are you going to have electrical linesmen going up and screwing the bulb in with a laptop in his hand and kind of programming each of those bulbs? Gosh, it'll take us decades to get the bulbs rolled out. You've got to have a solution where the guy goes out, he just pops it up, he has no clue what it is, he just shoves it in, presses a button, and goes to the next one, right? But then, what happens to the security? What happens to the fact that you got the wrong bulb that got in, you have something which is hacked in? How do you securely onboard these hundreds of thousands of devices that are needed to be secure? Because if you have the wrong kind of device going up and it's kind of tracking citizens' actions that it shouldn't be tracking, you're in trouble, right? So we basically recently launched, this is about a couple of weeks or something called an Intel Secure Device Onboard Ecosystem, which is effectively a mechanism. It's a broader ecosystem. As you can see, we have lots of partners in that effectively takes basis on something called EPID, which is what the industry's built for a long time, which is basically a mechanism where it allows you, in a secure but anonymous manner, know which group does particular device belong to. I'm oversimplifying it, but that's basically what it is. Without really finding out exactly what that particular device was, right? It helps you. I'm a light bulb and I belong to GE, for example, right? And how you bring that on board and how do you provision it and how you manage the whole life cycle. So that's just some of the solutions that use security. It solves a real problem because you also want to make sure the rolling out of these devices is secure, and you need it with an ecosystem, and that's an example of what we've been trying to do. Let me go to the next set of issues, right? You've got developer ecosystem and the resources in ecosystem is super critical, right? This cannot be done by one company alone. It has to be done by a large ecosystem of developers and companies coming together. And in order to do that, you've got to make sure that A, there's an ecosystem. Second, they have the resources to be successful. So some of the things that we realize, and I won't go in detail in this file except the last bullet, which is data that tells us is, belief is, based on various studies, we'll have about 4.5 million IoT developers at 2020. This is not just any kind of developers. These are developers building on IoT solutions, right? It's a large number of developers. How do you bring them on board? How do you make sure they are doing the right things? How do you make sure the right tools? So what we have as a company, and this is something which is not necessarily unique to Intel, there are many companies doing it as well, and we partner with them, is looking at various capabilities, right? On the left-hand side, on the right-hand side, sorry, you'll find the various sensors and stuff that comes in. In the middle, you find IDEs and, again, working with our ODM partners and stuff to get this together. And then you have various resources that are available. This could be development kits, could be anything else, to bring and make sure the development of these solutions is seamless, easy, and is not hard, right? That's the attempt. We heard about how hard it is to get a device to connect on the network, right? Which is true, because if you actually have a device and you have to go through certification, all the stuff, you're talking about a year and a half of work, and maybe $1 million of spending to get one device certified and go through all the network certifications, et cetera, et cetera. It's very hard for a typical small startup company or even medium-sized company to actually go drive it, right? So what we've done is, this is something we launched recently. It actually is going to hit the market in the next couple of weeks. Is in short, it's called Liquid, which is Intel LTE IoT quick deployment program. Effectively, what you see is a device, which is right now it's going to be the AT&T, but we'll launch with other carriers as well. It's a device which is certified. It's gone through all certifications. You can attach sensors to it. It's got a great user experience. It's got a device management system that you can actually manage life cycle. You can program with it, and you can basically use this device to connect your IoT solutions to the cloud without bothering about certification. It's certified already, right? So it takes that one thing off the table. It makes it a little less harder to be able to connect back to the cloud, right, or back to anywhere else. So that's what this device is about. Let's talk about artificial intelligence, right? The problem, we've gone through hype curves. So we've gone through various hype curves in prior technologies. Artificial intelligence is getting more real than what it was in the past. We'll see how fast adoption is. It looks all really nice and dandy right now, but we'll see how it evolves. But in order to make sure that your devices and your products and your solutions are artificial intelligence ready, or they're using artificial intelligence, getting into the IoT evolution from being smarter to autonomous, this is super critical, right? So here are some things in terms of what we've been doing with the industry and through our products and our ecosystem in kind of building a whole stack that starts right from the hardware capabilities that our products have, all the way up to various cloud services, APIs, development kits. If you walk out, we have something from Movidius and Nirvana. Movidius is a company acquired recently, and Nirvana acquired as well. They've got solutions in the AI space. And then as you move up in terms of how do you ensure the experiences are baked into the solutions you provide. So here are just some examples of the kind of things that we bring on the table to make life of developers easier as they're bringing artificial intelligence on their devices and solutions. Next, I'll talk about all of these things together, right? If you're in a business of IoT, you've got to make money quickly. You can't be waiting for 10 years to make money, right? You've got to have hardened devices and hardened offerings. You just can't go to the market with a science project and hope that it'll work. When it rains, it dies, you're in big trouble. So things have to be hardened to look at whether it's security or other things, it's got to be hardened. And the last thing is, it's a very complex and fragmented landscape, right? The IoT market is extremely fragmented. The amount of devices you can sell in a given market or given segment is very small compared to, for example, the PC industries, which is massive, right? And hence, a result of that, you've got to customize more. You've got to build solutions that are kind of half done, so you can build on that quickly, rather than building from scratch, because you cannot afford it. You'll be too late to market. So in line with that, the kind of things that we've been doing is, again, there's the larger ecosystem that we've been working with, and many of you are part of our ecosystem. And the thing that we also realized is it's really, really important to ensure you're bringing in market-ready solutions up, right? These are, we won't just bring ingredients and then give you a bag of parts and say, guys, go build something with it, let's see what happens. We want to work with our partners and our ecosystem partners to make sure we're building kind of a semi-done market-ready solution that you can deploy. You do not have to rethink about retail digital signage from scratch. It's there. Use it and do something new with it, right? Or for example, environment monitoring, right? We work with Bosch and recently, and so we had a lot of great engagement with them in terms of building and kind of an environment monitoring solution on the table pretty quickly. Or you're looking at predictive maintenance, right? You looked at the vibration harmonics of a given motor and figure out what do you do with it and when it's going to fail. Well, those heuristics and mechanisms are already baked and they're already there. You don't have to redo them. Just take the solution and then build something unique on top of it, which is going to be your USP, right? So that's the kind of way we're working with to make sure that we're bringing these market-ready solutions to the market so that you can take them and then run with it, and you don't have to wait for, oh my God, I got to harden the basic ingredients. They're all done. Build it and then do something unique and wonderful in that in solving a different problem. So in my view, we've talked about these 6 challenges that the industry has. I believe that it's really their opportunities, right? We've talked about certain things that we're doing. We're going to hear other speakers, of course, they talk about what they're doing as well. I think collectively as an industry, as an ecosystem, these challenges are really opportunities for all of us to tap upon and then take them to the next level. I'll basically end it here, where I talked about these 8 broad areas in terms of where IoT is transforming lives and changing things. from a pure business impact point of view, right? You look at IoT impact by 2027 is expected to be greater than $4 trillion per year. That is huge, right? We're all part of that game, we're all part of the journey, and we all need to work together to make the thing happen. And as we all work together and make IoT less harder, and we move from the hype to actually scale, I think that's when we'll transform the industry, we'll transform the business, and we'll transform ourselves. Thank you.
Thank you. Thank you. So I think we have time for around 3 to 4 questions from the audience. The mic is right here. Please shoot your questions. Can we have the mic out here, please?
Hi, my name is Lalit. My question is that, like, as you mentioned, that PC industry was big and hence there was a common denominator factor to build on. Now, you also mentioned that it's highly fragmented, this IoT industry is. Now, what are the key driving forces which is really uniting them? Because if it remains fragmented, then yes, sure, potential opportunities are large, but to have a connected, integrated, secured solutions, what are the key driving forces or even, specific bodies which are bringing them together? I mean, in a real, not just creating multiple standards, but really from a business point of view, they're coming together because there's a logic in it.
Speak it here? Yeah. So the reality is the industry, I don't see the industry becoming less fragmented. That's the way it is, right? An agricultural provider is not going to become a smart CNC machine creator, right? They're separate, right? So it will stay fragmented for a while, or it'll maybe forever. But the thing is that there are lots of common elements in that visible fragmentation. There are ingredients that are common. These ingredients is where you can potentially drive reuse across different segments, and that's where the economy of scale kind of come in, right? So one aspect is if you're looking at standards and industry activities happening at some of those levels, where you're trying to bring some of the key ingredients together. We talk about security as one area, right? Where you're bringing some of the security aspects together. That's a common problem across the industry. It's not just one vertical. So that's one area. We talked about some of the things like in terms of how do you get ubiquitous and quick connectivity to your solutions, which is a common problem across industry as well. And how do you kind of standardize things in that area where you don't have to kind of, you can start viewing them as more as a horizontal versus vertical. So in my view, some of those are the actions where as an industry we have to come on common ground on where the commonalities are, which are the horizontals, on which you can build different verticals. And I believe that way we can scale. I can't really say that the fragmentations at the vertical level is going to start coming down. It may even become more because there are going to be newer and newer things coming online which have different use cases. But as we start going down the stack, things become more common. And I think that's where we can drive scale and standardization across industry.
Hi, I'm Prakash. I saw you were talking about an IoT platform which is based on LTE. So one is it supporting narrowband IoT or is it standard, or what do you think as Intel's stand on narrowband IoT?
Yeah, it will. I mean, it's basically what you're looking at right now is we have a roadmap of offerings in that space, right? Which includes narrowband IoT as well. It'll happen whether it's CAT, narrowband IoT, whatever. That's on our roadmap of offerings that we're doing. This particular one, I'll have to go see exactly what spec, what bands, and what LT capability support. But it is designed at the first instance to support primarily for basically IoT solutions, and as we come up with future versions of this starting next year onwards, you'll find more and more which are more IoT specific offerings coming on the table. And by the way, it's not that we've built everything from scratch from inside. We're using stuff coming from the industry ourselves, right? As industry evolves, these things evolve as well. Out here, please.
Rahul, just a quick question about the Liquid platform. You mentioned that's already certified.
Yes.
As that comes out, but at some point it's also got to be connected to the cloud to do something, whatever you want to use it to sense. So how does that get handled?
How does it get handled?
Yeah. So which cloud services?
Sure. So it starts off with AT&T. That's the first carrier we are certifying with. It'll be certified when it actually hits the market in a few weeks from now. That is going to use the M2X cloud that AT&T has. That's the starting point. But we're also working with other providers to kind of use their IoT cloud infrastructure. And once you get in there, and then what we're also going to do is, that's one aspect of it, but if you look at device management that comes out of it, that's going to be potentially based on any of the other cloud providers, right? So you'll have to have the lifecycle management happening through some other cloud provider, which it'll actually be, out of the box, it'll work, right? So our idea is you don't buy something and then you open up a 600-page manual to see what button do I press. The idea is you buy the shelf, turn it on, and it goes. It does, the basic things are done. You press a few buttons, click it there, it's connected, and you can go ahead and solve your other problems and dealing with the cloud network and stuff, how things go back. And that's the idea. So that's how it's starting out with AT&T, but it'll launch to other networks as well as we progress.
Hello, this is Kuljit. I just have one query. In the last year, we have seen all the lower end of edge platforms being discontinued from Intel side. Means Galileo, Edison, and later the Joule itself. What is the plan? What is the path Intel is trying to take? Are you moving out of the lower end of compute, and can we expect some new platforms coming up in the recent years?
So I would not talk about roadmaps right now, right? I mean, some of the things, talking about roadmap decisions that Intel's taken, they get taken all the time. We look at a market, we stay in it for a while, and then we evolve. So that's what you see going on right now. All I can say is that IoT is a priority for Intel, right? And we're not getting out of IoT, right? I mean, if you look at even our results last year, we got announced with great amount of growth that's happening, which beats even the industry, where the industry headed. So I think overall, I mean, all I can share at this point in time is IoT is high priority for Intel. We are in it for the long haul. We've been there for a long time. We'll be there for a long time. And roadmaps keep changing. It's a very rapidly evolving industry, so we will change roadmaps, we will bring new things, and some of the things you saw right now which I talked about, it's talking about how Intel is actually being able to provide market-ready solutions and things versus just a bag of parts, right? That's where the industry is going, that's what the industry needs, that's what we're doing, right? So I think roadmaps will keep changing. It's the world, that's the way it works.
Good morning, sir. Myself, Omkar. I just wanted to know, since already we are on the age of automation of everything, so for that purpose, we may require energy also, the kind of electricity or the battery backup. So is there any research going on to have a lesser consumption to provide a more energy for these solutions?
Are you talking about in Intel or generally?
In general.
I am pretty sure there is, right? I mean, you see new battery technology. I'm not an expert in that area, so I can't speak much, but as a company at Intel, energy is a big area for us, right? Yeah. Because if you look at it, the power consumptions of our devices, generation over generation, either it's performance per watt, or it's going to be in terms of things like standby power and so on and so on. The power keeps coming down. That's our goal. When we design products, we design with power in mind from the get-go versus as an afterthought, like security is, for example. Yeah. So answer is yes. As an industry, we're working towards it. Have we solved it yet? I don't think so. I think we have a long ways to go. But I think we work closely with our partners, closely with our R&D teams to make sure we are handling those things as the industry needs. But what's going on in the broader industry in terms of energy, I'm not the right person to speak about those.
Thank you, sir.
Thank you, ladies and gentlemen. Thank you, Rahul. I would request, Rahul, just a minute. I would request Vikram Labhe, Managing Director of Microsemi and former board member of ISA, to come on stage and give a token of appreciation to Rahul, please.